Hey guys, today we are going to take up a project that concerns the New York City taxi ride. So New York primarily has about two different taxi rides, that's the green and the yellow cabs. So we have taken up data for the New York City yellow taxi rides and we're going to do some analysis on that. So we're a team of five, Akhilesh, Amit, myself, Roma and Sanjay. So here's a little background about the New York taxi services. So the city has around 13,000 yellow cabs. It takes about 500,000 tips a day, 70 million rides a year. And each ride, takes about 12 to 13 minutes and costs about $14, 14 USDs. And it also includes some tip, toll taxes and everything. So here's what we want to do with the analysis. We want to, take the yellow taxi cab and see the demand patterns. We want to see what are the pickup and drop locations, what are the spikes. Do people take more cabs during the certain time of the year, during certain time of the day? What are the number of hours? What are the number of other variables that we're going to consider? So and we're also going to look at the correlations between different variables. So our data source comes in from the New York Taxi and Limousine Commission. It has about 17 million taxi trips. We are also taking into account location data, so we plotted on the New York City map. We are looking at trip distance, toll fares, and other parameters that we have in the data set. So merging the data itself was a problem because each data set was divided into monthly basis. So we took the data from January 2015 and Feb 2015 only for the yellow cap. So we omitted the green cap data. Merging it on the local machine was difficult, so we had to use Amazon Web Services, hosting the data on Amazon S3. So why do we use Amazon? Scalable is one factor. Yes, we can scale up our data anytime we want. We can reuse the code that we have using Jupyter Notebooks. And these datasets are available publicly. So if I go and make the data available public on S3, my teammates and other members on the same region that Amazon provides makes it easy for everyone to use it.
What we did was we configured EC2 server. However, because of the large data set, we actually we needed more CPUs. So we needed 16 CPUs. We need a memory of 64 GB, and we also used a RAM of 32 GB. We required such a configuration in order to read more than nearly 3 GB of data. So this is some of the exploratory analysis that we came up with on the data set. So if you see, there are two vendors, Verifone and Creative Mobile Tech, and both have pretty much the same amount of transactions in the data set that we did, around 9 million for Verifone and 8 million for Creative Mobile Tech. So then we look at what we did was we compared the rate code versus the average revenue. For example, there are different rates. There are standard rates, there is a JFK rate, there is a NEVOC rate. So we found that the average revenue is highest for NEVOC for both vendors. However, the lowest average revenue is for the group rides. So this is some of the insights that we got from the data. Now, when it comes to the cluster map, we found that generally the group riders are more likely to pay by cash, which is kind of interesting because we were looking at patterns with respect to payments. With how is it with group riders and with solo travelers? We also found that the no charge case is very low at 0.2.
So why do people use credit card in the US? It could be primarily only for maintaining credit score because the more the credit card you use, it gives you a better chance to maintaining your credit score and that helps you in the loans in the future. And another reason could be that US has greater denominations than other countries, so they have pennies, cents, and quarters, which makes it really difficult to carry change that you get, back from the cab drivers. So here are some maps that we use. We're using the base map libraries in Python. And if you look at the data, these are pickup points on the map. So you see that Manhattan, Times Square, and Central Park. So the central part of the city has more pickup points on the map. And similarly, if you see the drop points in this map, you see that it's more widespread. So that people do get dropped off in the center part of the city, but while they're going home in the evening, it spans to say Queen, the JFK Airport, and New Jersey City. So it pretty much takes off between the city center and the suburbs when it comes to the drop-off locations. So another thing that we did was we had data in the form of dates and time of the year of the day. So we looked at some time series analysis. We see that the average number of trips in a day is close to 5,000, but we do see that there's a sudden drop towards the end of the month. So that's around the 27th of Jan and Feb. This could be that people, primarily run out of money during the end of the month. So that could be another factor that we see the drop there. If you look at the hour of the day, there's a peak traffic towards the end of the office hours season, but there's a sudden drop that goes on from midnight to say about 5 a.m. During the day. That's the least that's the hour where people use the least number of taxi services. So the challenges that we faced for the data was really huge. I mean, gigabytes of data, merging that data on the local is not difficult, so we had to use AWS. Then data formatting, when we used the time series analysis using the date fields, was another challenge. And the file was really big, and just using the latitude and longitude on the map was another problem because we had to import different libraries. So what more can be done on this data? Well, you can look at why there are more single passengers. The government can look into it. And for a country that's really promising and looking to cut down on the carbon footprint, that could be a problem because you just have taxi services which have just one people. Unique car IDs could be another thing. And but what's this Vision Zero plan, Sanjay?
So basically, the governor of New York has a Vision Zero plan to cut down on accidents and probably have zero accidents. So the agencies need more data analysis on taxis with respect to the taxi registration numbers, how individual taxis perform. Are they driving rash? Are they having any anomalies there? So that's what the plan is, to make use of the data and come out with more analysis. That ends our analysis, and I hope the analysis has been good.
Yeah. Thank you, guys. Thank you.